questions. Exercise 1.1 board syllabus. Determine the relation capital R defined as y equal to x plus 5 and x is less than 4. X is belongs to capital N. Here x belongs to capital N, and given that x is less than 4, x is less than 4 means we can take x equal to 1, 2, 3. Therefore, y is equal to x plus 5. Then first x equal to 1, then y equal to 1 plus 5, 6, x equal to 2, y equal to 2 plus 5, 7, x equal to 3, y equal to 3 plus 5, that is equal to 8. Therefore, the relation capital R defined as on capital N, defined as 1 6 2 7 2 7 3 8 3 8. Now the main set capital N is equal to the set of 1, 2, 3 natural number set and so on for. Here number 1, reflexive property. Reflexive. Number 1, verification for reflexive. Here 1 belongs to main set capital N. Therefore, is 1 comma 1 belongs to capital R? No. Therefore, 1 comma 1 not belongs to capital R. Therefore, R is not reflexive. Next, number 2, symmetric. Number 2, symmetric. Test for symmetric. Here 1 comma 6. Here 1 comma 6 that belongs to capital R. Let us take first element 1 comma 6. Is implies 6 comma 1 belongs to capital R? No. Therefore, if 1 comma 6 belongs to capital R, then 6 comma 1 does not belongs to capital R. Therefore, capital R is not symmetric. Not symmetric. Next, number 3, transitive. Transitive or transitivity. Transitive. Test for transitivity. Here 1 comma 6 that is belongs to capital R, but starting with the 6 comma something means there is no element starting with 6. It is does not exist in capital R. Though R is transitive. R is transitive. Refer basic points. R is transitive. Therefore, capital R is only transitive. Only transitive. But not reflexive and symmetric. Over. This is the procedure. Next, I wish to introduce the second method for the same question. So this is the second method. Second method. Capital R is equal to the set of x comma y, so that y is divisible by x, means x divides y, or we can say that y is divisible by x. Here capital A means 1, 2, 3, 4, 5, 6 all are belongs to natural numbers. So therefore capital A is a subset of natural numbers. We have to observe natural number set and divides, the word divides. So first verification of reflexive property. Actually on capital N natural number sets, on capital N, x divides x comma x belongs to natural number, means every number divides itself. Every number is divisible by itself. 2 divides 2, 1 divides 1, 3 divides 3, 4 divides 4, and so on, just like that. What does it mean? That is for all x belongs to capital A. Of course, it is subset of natural number. The ordered pair x comma x, that is belongs to capital R. Therefore, R is reflexive. R is reflexive. Next, number 2, symmetrical property. Symmetric. On capital N, generally when x divides y, then y does not divides x. Example, 2 divides 4, but 4 does not divides 2, just like that. Means 4 is divisible by 2, but 2 is not divisible by 4. Here, what does it mean? 2 divides 4. 4 is divisible by 2. What does it mean? 2 is not divisible by 4, just like that. So the relation divides, it is not symmetric. So therefore if x comma y, that is belongs to capital R, then y comma x not belongs to capital R. Therefore R is not symmetric. R is not symmetric on capital A. A means it is subset of natural number set. This is the simple proof. Next, transitive. Number 3, transitive. For example, first I will show the example. 2 divides 4. 2 divides 4. Here 2 rough work. 2 divides 4. 2 divides divides 4. 2 divides 4. What does it mean? 4 is divisible by 2. Next, 4 divides 8. What does it mean? 8 is divisible by 4. These are the meanings. Then 2 divides 8. 2 divides 8. What does it mean? 8 is divisible by 2. So it is correct. Thus let x comma y belongs to capital R and y comma z belongs to capital R. X comma y belongs to capital R means what? X divides, I wrote here, x divides y. What does it mean? Y divides z. Y divides z. Therefore, clearly on capital N, x divides z. Therefore x comma z also belongs to capital R. Therefore x comma y comma z, it is belongs to capital A. Of course it is subset of natural number, and if x comma y and y comma z, that is belongs to capital R, then x comma z also belongs to capital R. Therefore R is transitive. R is transitive. Okay, we should make a note here on natural number set. On natural number set, the relation divides is number 1 reflexive, number 2 transitive, but not symmetric, we have to learn this inference in this question. Understand? Finish. Over. Next question. Capital R defined as x and y living in the same locality. Remember, one shortcut is there. In capital R, if it is given the word same, similar, equal, parallel, next congruent means it's a symbol like that. Already you did know the symbol parallel like that. 1, 2, 3, 4, 5. 5 words are there. This word 5 words means any word. Same or similar or equal or parallel or congruent. These words are there in capital R. Definitely this capital R is equivalence relation. This is the shortcut. Bluntly, you can represent in any competitive examination equivalent relation. Okay, come to the solution. So, in board level, we have to write all the steps. Capital R is living in the same. Here, letter X. X means one person. X means one person. It is belongs to the set capital A. Capital A. In capital A, one person is there. X actually X and X living in the same locality. We can say like that. Therefore, X comma X, it is belongs to capital R. Thus, capital R is reflexive. Simple proof. Capital R is reflexive. Next, symmetrical. Let X comma Y, that is belongs to capital R, means that X and Y are living in the same locality. So in English language we can write it as X and Y, means we can write Y and X. Y and X are living in the same locality. So this sentence can be written as or expressed as the ordered pair of Y comma X, that is belongs to capital R. Therefore, if X comma Y belongs to capital R, then Y comma X is also belong to capital R. Therefore, capital R is symmetric. Capital R is symmetric. Over. Next, transitive. For transitive, next, transitivity. Okay, test for transitivity. Actually, the definition of transitive property is what? If A comma B, I wish to recall once again the definition of transitivity. A comma B and B comma C are belongs to capital R. Remember, it is ending with a B, it is starting with a B. Okay, both are same. Then A comma C belongs to capital R. It is transitivity. Okay. Even if B comma C not belongs to capital R or does not exist in capital R, then also capital R is transitive. Capital R is transitive. This is the complete definition of transitive. Okay. For which we assume these two elements in capital R. Let X comma Y belongs to capital R and Y comma Z, that is belongs to capital R. So what does it mean? It means that X and Y are living in the same locality. Next, Y comma Z belongs to capital R. Means what? Means that Y and Z are living in the same locality. So here in this plane X, Y, he is X, he is Y. X, Y are lie in this plane, suppose pi. Next, Y, Z. These two are also in the same plane. Then definitely clearly we see that X and Z are lie in the same plane, in the same sensor, So clearly we see that X and Z are living in the same locality, that is, it is represented as X comma Z is also belongs to capital R. Therefore X comma Y and Y comma Z belongs to capital R, which gives or implies X comma Z is also belongs to capital R. So definition is satisfied. Therefore capital R is transitive. Capital R is transitive. Hence, therefore, capital R is reflexive and symmetric and transitive. Therefore, clearly capital R is equivalence relation on the human being set capital A, on the main set capital A. A means the set of human beings. Okay, this is over.